Okay, on 3.3, there was a question on 2. Find the real solutions of the equation 2x squared plus 7x minus 4 equals 0. We could try factoring. That would be 2x times x would make 2x squared. And to multiply to be negative 4, it could be 2 and a negative 2, or negative 2 and 2, or 1 and 4, vice versa. I think it's going to be 4 over here, because that would make 8, and 1. 1 times 4 is 4, and I need to make one of these negative. I want a plus 7, so this 8 must be plus, and this 1 must be minus. That would give us negative 4 on the end. It would give us plus 8 on the outsides, negative 1x on the inside, which would be plus 7x in the middle. So that's how it factors. So the real solutions would be whatever makes this be 0. So we're going to write 2x minus 1 equals 0. Add 1. Divide by 2. There's one real solution. And I'm going to set x plus 4 equal to 0. Subtract 4. And I get x equals negative 4. There's the two solutions. And it says, number 3 says now, to complete the square on x squared minus 5x, you would add the number. Well, you would take half of the b, which would be negative 5 halves, and square it. So negative 5 times negative 5 is 25, and 2 times 2 is 4, and that's the number you would add to complete this square. This would make a perfect square. That's x minus 5 halves on one side and x minus 5 halves on the other side. That's 2 and 3. Now we jump clear down to 28 for the next question. 28 said we have f of x is 3x squared plus 6x, and graph the function f by starting with the parent function y equals x squared, shifting and compressing and stretching and or reflecting. Well, to do that we needed to get this in that shift, compress, reflect everything. So we're going to complete the square on it by first factoring out the 3. There's no constant, so I can just leave that outside, and then I have to add something and subtract something. Well, half of 2, because I always do half of b, which is 1, and square it, and that's what I'm going to add and subtract. So now this part is a perfect square. That's x plus 1, half of b, squared, with a 3 on it. And then the 3 outside would be times that minus 1, so that'd be minus 3. And so if I were to graph this, the translations I would have to go through. Inside, the x plus 1 would mean it's left 1, because inside on the x goes left or right. And then the outside, we have to do them in order of operations. 3 times is a multiply, and this does what it says, so it makes it 3 times is called vertically. Vertically stretch by 3 times. And then the in 3 says move up 3. So going through those on a graph, I hope you can see this. The parabola normally goes through 0, 1, 1, and 2, 4. That's where it would start. Left 1 would take it over to here. vertically stretched by 3, instead of 1 over and up 1, it would be up 3. So now I'm going to draw that. So go back 1, and if I move over 1, instead of being up 1, it's going to be up to 3. And 1 over, it's going to be up to 3. So that's vertically stretched. And I need to put some units on here. 1 and 1, and this is minus 1 and 3. So now you can see where it goes. This is minus 2, 3. And then up 3. So then this one would go at minus 1. It would go up 3. So the vertex would be there. Then if I go over 1, it's going to be up 3 more. So that's be up at 6. And up at 6 at negative 2. This is 6, and this is negative 2, negative 1. So you have to kind of complete the square before you can know the translations to get to it. Okay? That's what they wanted you to do on 28. Now let's do, let's say, 68 was asked about. And 68 says h of x is negative 3x plus 1 quantity squared plus 4. And it said graph the function, determine the domain and range, and determine if the function's where it's increasing or decreasing. Well, this one's pretty easy to graph because this is the vertex form. It has a vertex at negative 1, 4. Negative 1 because it always works opposite inside the parent function. Outside works the same, so it's at plus 4. It's upside down, and it's going 3 times as fast. So normally a parabola over 1 would be down 1, but it's going to be down 3 and down 3. And 2 over would have been down 4 times 3 is 12. 12 from 4 is down at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's way down there at 1 and way down there at negative 3. Okay, so we were supposed to, that's the graph of it. And let's see, we were supposed to determine the domain. Domain is all reals because it's, you can put any value in for x from negative infinity to positive infinity. So the domain is from negative infinity to positive infinity, or you could say all reals. The range is, well, the highest is 4, the lowest is negative infinity, so it goes from negative infinity up to a positive 4. Notice I put the smallest to the largest. And then determine where the function is increasing. So it's going up as I read left to right for all the x's all the way up till negative 1. From negative infinity till negative 1 on the x, this function is increasing. For all these x's, it's going up. And it's decreasing after negative 1. From negative 1 to infinity, this will be going down. So that's the interval of decreasing, increasing, range, domain, and the graph. And that's all they asked for on 68.